Hello students, welcome to this lecture number 6 on the state of matter chapters. In this lecture we are again going to discuss a very important topic, that is the Graham law of diffusion. This is a very important concept and this concept will help you solve many numericals that is going to come in your NEET exam or in your other board exams. The Graham's law of diffusion today we are going to discuss. So today's lecture we will going to discuss the Graham's law of diffusion. Before going to discuss this Graham law of diffusion, let us first understand what we have learned from the previous 5 videos. In the first video, that was basically the introduction to the state of matters. In this lecture we have discussed about the reason behind the different states of matters, and we have understand from this lecture that it is the balancing between the two energies, that is the thermal energy and the intermolecular attraction energy, that is going to attribute all those state of matters. And in that relation we have also discussed about the different types of attractive forces and repulsive forces. If you want to know details about all those things, you must watch this video. And second lecture we have discussed about the gaseous state. In the gaseous state we have discussed the two important laws, that is the Boyle's law and the Charles law. And we understand how Boyle's law and Charles law has been formulated by the different scientists and how it is going to help us to understand the state of the gas. In the third lecture we have discussed about the Avogadro's law as well as the Hamilton's law, which will give also different type of relationship of the state of the gas in different way. And in the fourth lecture we have combined all those 3 laws, that is the Boyle's law, Charles law and the Avogadro's law, into one equation, that is the ideal state equations, and different type of numericals in the respective lectures we have already understood. In the fifth lecture we have discussed about the Dalton law of partial pressure and how do we able to correlate with the mole functions and with the partial pressure of the gas, that we have also discussed. So if you have not watched this lecture, maybe you are watching this lecture for the first time, for your reference I am telling you, you can go through this. You will just type that science with Mukherjee sir and you will get all the play list and you will go through this and you will get the total of these lectures, content of the lectures. Now we are going to discuss the Graham's law of diffusions. Graham's law of diffusion, in practically if we think that suppose there is a 2 gases mixes, and how do we able to separate all these gases from each other? Then we will apply this law, Graham's law of diffusion, and this will help us to separate the gases from their mixtures, and this process is also called the atomolysis. Atomolysis, it is basically a separation of the gases, 2 gases from each other due to the difference in their differences, and this has been successfully implemented in different cases that we will discuss later on. First let us understand what is Graham law of diffusions. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So what is Graham's law of diffusion? Let us understand what it says. It says at constant temperature and pressure. See, in the gaseous law, what we have observed, there is basically 4 variables: volume, temperature, pressure and amount of gas. And 2 of the variables we have to fix to understand the correlation of other 2 variables. And in this way, here also you can see constant temperature and pressure. The Graham's law says the rate of diffusion of different gases, different densities of gas. So what it says that at constant temperature and pressure, the rate of diffusions of different gas is inversely proportional to the square root of the density. So suppose the rate of diffusion is R, at that time we can correlate with the density in this way. This is the Graham's law of diffusion. And we know density is directly proportional to the molecular mass. So we can again also write this 1 by m. M is the molecular mass of the gas. So we can write this equation in this way for the 2 gases. Suppose R1 and R2, the rate of diffusion of the 2 gases. So at that time we can write d1 d2 by d1, and this is again you can write it in this way, that is m2 by m1. So how we can say that this is the first law, that is you can write here R1 by R2 is equal to d2 by d1, and it is m2 by m1. This is the first relationship when we keep the temperature and pressure constant. This is the first one. Now you will understand the second one. Second one, at that time, what is there? Suppose the gas is diffusing at the constant temperature but with a different pressure. Then what is going to happen? Higher will be the pressure, then the number of molecules which will hit the container surface will be higher. If we increase the pressure of the gas, at that time number of molecules that will hit the surface of the vessel will be higher, and at that time you will find the rate of diffusion will be higher. So with the pressure, we will see that is directly related to the rate of diffusion is directly related to the pressure. So again we can say the next one, that is we can write R1 by R2 is equal to P1 by P2 into D2 by D1. Okay, so it will again we can write that P1 by P2 into M2 by M1. So this is the second relation where the temperature is constant and pressure is changing. So this is the second formula that we must remember. R1 by R2, that is P1 by P2 into M2 by M1, or we can write P1 by P2, that is D2 by D1. This is the second one. Now what about the third one? Third one, in this case, what we do, we will keep the pressure constant. We will keep the pressure constant, but at the same time, what we will do, we will change the temperature. So at that time, what will be the relation? Relation will be like this: R1 by R2. It will be directly proportional to the square root of the temperature, and in the formula we will also write the density also. And this can be further written, that is T1 by T2 into M2 by M1. Okay, so this is the third relation. Third relation with the diffusion and the temperature and density and your molecular mass. Fourth one, suppose we know rate of diffusion. What is rate of diffusion? Rate of diffusion R. Rate of diffusion R is equal to volume diffused divided by time taken. Volume diffused divided by time taken. So we can write this in this fashion, that R is equal to V by T. So we can write this expression V1 by T1, V2 by T2, V1 by T1, V2 by T2, that is, we can write D2 by D1. But D2 and D1 is the density of the gas. So in these cases, there will be two. For this, there will be two cases. Number one, when T1 is equal to T2. Although time diffuse will be same. This type of question numerical will do. When T1 is equal to T2, at that time, this relation will be V1 by V2, that will be D2 by D1. Okay? So what it means? It means that when the diffusion, time of the diffusion is same, at that time how the volume diffused will correlate with this density, or we can say it will be in terms of molecular mass M2 by M1. So at that time you can see it is inversely proportional, means higher will be the density or higher will be the molecular mass of this gas, then the diffusion volume diffused will be lower, and that is logical also, because if the density higher by molecular mass is higher, at that time it will take time to diffuse. Okay, and this is the one relation. And second relation is when V1 is equal to V2, at that time you can see time. What about the time? Time is equal to T2 by T1 will be directly proportional to their density, and it is also logical. When volume diffuse will be same, at that time what is going to happen? The time taken to diffuse that volume will depend on the molecular mass. Higher the molecular mass, higher will be the time. So it will be directly proportional to the time. So we understand different relationship as per Graham's law with the diffusion rate with the different factors. That is, first we understand about the density, molecular mass, pressure, absolute temperature, then time of the diffusion, then amount of the diffusion. Okay. Now we do some exercise that will again help us to understand this concept more clearly. Now we are going to discuss a very important phenomenon that is called the atmolysis. Atmolysis, what is atmolysis? It is basically the separation of the two gases. We can write is separation of two gases, separation of two gases. Formed by diffusion. By diffusion on the respect of different densities. Because of the different density, the gas will diffusion rate of the gas will be different. And at that time, what is going to happen? One gas will diffuse very fast, and other will be, the diffusion rate will be lower. In this way, we can able to separate the one gas from the other gas, and this process is called the atmolysis. And in this way, successfully, that is implemented when there is a mixture of the uranium with the gaseous mixture. You can able to separate out the uranium. That is a very practical example. Now let us some question I am going to give. Suppose there is three tires. We know tire is having some tubes, and this tube has been filled with the three gases. So one tube, that is a tube, suppose it's tube. In this tube, that is nitrogen gas in the same pressure has been filled. Another tube, you can see, that is we are giving the helium gas, suppose, right? And another tube we are giving the hydrogen gas. So you have to say in which tube. First thing that we have to understand, whether when we are filling this gas in this tube, whether it will be taking the same time or different time. That is question number one. The diffusion, when the gas has been filled to these tubes, that will be taking same time or different time. From the diffusion, Graham's law of diffusion, we know that diffusion rate is inversely proportional to the square root of the molecular mass. If we go by this, what we will find? The hydrogen will have the lower mass, followed by helium, and followed by nitrogen. So hydrogen, when we filled the tube of the car with the hydrogen, it will take less time as compared to the other two. So we understand how the diffusion law of Graham's law of diffusion going to help us. This type of question will come. One question that I quote, that is that has came in your exams, AITPA, and this question I am going to give you. And from this also you can understand how important this chapter is. मेरा दिल में बाबा तेरा प्यार ऐसा छा गया. Suppose R M and P is the rate of diffusion, molecule PA by PB root MB by MA. Second, RA by RB, PA by PB, MA by MB. This question came in the year AIEEE 2010, and they say which will be the none of the above. Then which will be the correct relationship? We know from the Gram's diffusion law that relation between the rate of diffusion is directly proportional to the pressure, and rate of diffusion is inversely proportional to the square root of the molecular mass. So if you see from this relation, this A will be the correct answer. RA, that is directly proportional, and it is inversely proportional in square root of the molecular mass. So this will be the correct answer. Grams of hydrogen, 2 grams of hydrogen diffuse in 10 minutes. How much of oxygen diffuse in same time and same condition? This is the question. 2 grams of hydrogen diffuse in 10 minutes. How much of oxygen diffuse in the same time? So we know R1 by R2. Here T is same. R1, R2, you can see that is V1 by V2, and it is M2 by M1. And we know this V is directly proportional to the moles. So suppose X gram of oxygen diffuse. Okay, so we can write this equation because V is directly proportional to the moles, so we can write N1 that is for the hydrogen and N2 for the oxygen. So it will be given by M2 by M1 Now, what is N1? N1 is 2 by 2, 1 mole of hydrogen, and N2, 2 by 2, that is 1, and N2 we know that x we have to calculate divided by 32. So we will just put this point here. 1 divided by x by 32 is equal to 2 by 32. Sorry, this will be 32 and this is 2. Okay, so this will be 32 by x is equal to, it will be 4. Okay, so from this we can have the x is equal to 8 gram. So when the 2 grams of hydrogen diffuse in 10 minutes, if we keep the oxygen, it will diffuse and its amount will be 8 gram. Okay, that is all for today's lecture. In this lecture we have discussed about the Graham's law of diffusion. That is a very important one, and 1 or 2 questions is going to come in your board exam or in IIT JEE. So you must go through this lecture, and thank you for watching this. And the next lecture we will be going to discuss the kinetic theory of the gases. Again, this is a very important thing. It is all for today's lecture. Thank you very much for watching.